Hey, everybody. It is 2 hours UTC, and this is once again Astronomy Daily Live. Hey, everybody. You can call me Cosmic, and welcome. Glad everybody could stop in. Those of you who are watching live and in person, and those of you who are watching this later in the future. Hope everybody's doing well. Hope your past 23 hours was a nice one. Mine was pretty good, pretty interesting. Wanted to give you an update on my telescope and CCD project. Uh, good, uh, good motion forward on that today. But yeah, I'll sort of hang here for a little bit, see if anybody else wants to jump in before I get going on that. Also found an interesting paper that was put up on archive.org last Tuesday, the 6th of March, 2018. You saw that prior to me actually starting. It's talking about one of the instruments on the JUICE mission that is slated, I think, to launch in 2022, arrive at Jupiter at 2029. So yeah, I'll get into that. Looks pretty interesting. I was looking at it before this live stream a little bit, and I'm very much a sucker when it comes to anything to do with Jupiter and its system. It no particular reason. It's just uh, yeah, there. It just gives me uh, a nice, warm, fuzzy feeling when I think of Jupiter and studying it, and very um, 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 amazing planet and system of moons and rings, and yeah, pretty amazing place for sure. So we'll get into that a little bit. This is just a live daily, very casual, very fun, hopefully educational both for you and for me. um, and you know, I started this because one, I um, um, my nights here are usually free and open, and I sit around and I think about astronomy, and I read papers, and I look at all the tweets, and I look at all the YouTube channels. I watch Weekly Space Hangout with Fraser Kane. I watch Deep Astronomy with Tony uh, Tony Durnell, Purnell, Durnell. Oh, sorry, Tony. My bad. Let me get it here. I've got it. This is the fun thing about being live, is that you just get to see all the quote unquote mistakes. But why do I need to produce this kind of stuff when I'm just having fun? So what I wanted to do was, I don't even know what it's called. I'm looking for a particular file. Sorry, topics. That's it. Topics. Tony Darnell. Tony Darnell. I'm sorry, Tony. My my bad. My bad. Uh, so I'm watching that. I watch some CosmoQuest things over on Twitch. Um, I haven't lately, but uh, I do like to get over to Dennis Hans's um, Periscope thing. He does uh, a live show. It's basically like a little quiz. Um, that he uses as a format, to talk about astronomical things, and it's very, very awesome. And he was very inspiring to me, to go sort of the live route. Um, so yeah, I'm sitting around here anyway at 2 hours UTC um, every single day. Now I'm in southeastern Arizona, so I'm 7 hours behind UTC. So that makes it currently 7:05 p.m. Mountain Standard Time in the United States, of course. Um, so, I'm sitting around here in the evenings. My brain is just a little tired because I've been working all day. I'm usually up by 4 or 5, and uh, pretty much as soon as I wake up, I'm working. And so I work on my things for several hours in the morning, and then I go to my day job to pay the bills, and I get home from that, um, eat some dinner, and I'm sitting here, and my brain is tired, just wants to think astronomy, or software, or science in general. That's how I relax. That's how I sit back and enjoy things. So my main motivation is like, if I'm going to be doing this anyway, why not uh, share it with the entire world, and specifically, share it with a group of friends um, who share the same passion and the same topics and all of that. So it's like, why not? But I also noticed, that there were some holes in the current uh, um, sort of astronomy podcast universe. Uh, in that, there wasn't, as far as I know, there still isn't, except mine now, a daily live stream. Um, both, yeah, there are live streams, but they're weekly or a couple times a week. Uh, Even the Twitch ones, are just 1 or 2 days a week or so. So I thought, I'm sitting here anyway. I'm thinking astronomy anyway, every single day. Why not just do it every single day and fill that niche, right? The other thing is that uh, I've I've been involved in um, many aspects of astronomy. I was new once. Um, I was an amateur once. I was a professional once, and now I'm all of those. I consider myself every single one. So I like to talk astronomy at any level that anybody wants to. Um, it's really, really fun. I thoroughly enjoy it. I'm going to pull up my Twitch. Uncle Bill is in the house waving, and Tom is in the house too. Thank you guys for coming in again. I appreciate. I really do appreciate the support. It's uh, it's hard to get started with these kinds of things. Get the attention and all that. And you guys are hanging with me, and I appreciate that. I think that's extremely, extremely awesome. So glad you're here. Um, yeah, this is just unrehearsed, pretty much unplanned. I, I start to think about, maybe, some things, to talk about, but really a lot of this is just unplanned, get together. You know, it's as if, um, you drove up to my house here, and we sat around the fire under the sky, and talked astronomy for an hour, and it's just very, very loose, very, very casual. But at the same time, this is science. So very, very skeptical. Very, um, any um, any idea uh, uh, should be looked at really, really, really hard. But at the same time, you need to be open-minded. So you can't, you know, close your head off to things that sound ridiculous or don't understand, or don't have, the perspective that is needed, to really, really grasp these things. A lot of astronomical topics are uh, very, very complicated, and I think a lot of the complication has to do with, how we humans um, interpret things. I think, how we do that, how we measure, is probably pretty crude. Uh, I'm in the same box, so it's sort of like, well, what else is there? I don't know, but there probably is, because the universe operates, um, what seems to be, um, effortlessly. In fact, Buckminster Fuller uh, said that, um, um, the universe. Oh, I forget exactly how he put it, so I'm going to paraphrase in a very, very rough way. But the universe does everything with absolutely no effort at all, and that's sort of the ultimate. If you want, like a perpetual motion machine, you've you've got one. You're living in one, and yeah. So I think that's pretty awesome. So glad everybody is here. Glad everybody could join in. It's wow. It's coming up on the spring equinox. The spring equinox is coming up on March 20th. So that's just a wow. That's just a few days. A few days from now, like 11 11 days from now is the spring equinox. Pretty awesome. Pretty awesome. Hope your equinox is going to be nice. It's this time around, my local, or well, the equinox here coincides with a local time of 9:15 a.m. So I'm probably going to do some kind of a sunrise um, sunrise equinox photograph, and probably not a ceremony or anything, but definitely photograph you the sunrise on the day of the equinox. Um, the equinoxes are my favorite days of the year. They're sort of like holidays. So and I'm lucky enough that I am going to be taking off that day to just relax, just sit back and enjoy a little bit. Now, probably that won't happen because you know I'll get distracted with something, and then I'll end up working all day long. So, but whatever. My attitude is, as long as you're having fun, uh, who cares, right? Who cares? Because you know, if I'm having fun, I definitely can't call it work. Work is, you know, is an activity that you would much rather not be doing, but you have to. And wow, I don't think I've really done that in many years. So tried to have as much fun as I possibly could, and for the most part, that works out. Sometimes rough to pay all the bills, but we can deal with that. That's a small price to pay. Cheers. So the hope everybody saw the um, um, article that I posted over on my Discord server. It's just, I called it a head slapper of the day. It's like, oh man, wow. This lady, I haven't read the article yet. I need to. I need to. But at least, the very, very short description it gave was that this lady was skydiving, right? And she was up at 14,500 feet, and she jumped, and her parachute her parachute didn't open, and so she crashed. She crashed onto the ground, but She landed in this fire ant. she 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 landed in this fire ant hill, and um, of course the fire ants attacked her, right, shooting all this venom into her, which gave her um, uh, like this huge uh, um, um, adrenaline rush that kept her heart beating. And I'm thinking it's like her heart was intact, but she, I have to read the article because I'm really, really curious about the nature of this fire ant hill. Okay, you know, I mean to be able to uh, sort of soften the landing a little bit, wouldn't it would have to be sort of both pretty big and sort of fluffy, right? Maybe porous. I mean, anthills, I guess, are, but yeah, I actually think that that's the most amazing thing is that yeah, she survived. Well, there's a lot of amazing things about this story. One, the poor lady, her parachute didn't open. Okay, and I've thought about that. I've thought about that. It's like, okay, what what's going to be going through my head when I realize that the parachute isn't going to open and I'm hurtling, at critical speed towards the ground. Um, you know, Kitty, and you've got quite a bit of time. You've got quite a bit of time to think about things, and yeah, so that's very extraordinary. Okay, that in and of itself, and unfortunately, that's happened a lot. Luckily, not all that often, but it's happened, right? Um, uh, so that's extraordinary. To sort of think about, you've got, I don't know, a couple. I mean, do you have a couple of minutes? Do you have half a minute? I'm not exactly sure. It'd be easy enough to figure out how long it takes to fall that far. But you've got a substantial amount of time, right? A substantial amount of time, and so you're dropping and you're seeing the ground, just coming up and up and up and up and up, and you've got a lot of time to think about it. But then the extraordinary thing is that she lands on this ant hill, and and is cushioned enough to be alive when she lands. She doesn't go splat. She doesn't go splat, right? She goes or something, right? So I'm really interested in the nature of this anthill. See, I mean, it's a scientist. It comes out in me and everything. So, oh, her secondary parachute opened. Okay, all right. So it wasn't as if she was going, 8,000 miles an hour into this anthill. as I said, I need to read the article still. I see these things, and I'm just too busy um, at the moment, to read it. But it's like, oh my God. Um, so yeah, okay. So Tom is saying her secondary parachute opened, but she was rotating, uh, and, and it didn't fully deploy. Yeah, but any kind of drag at all, is going to slow her down a little bit. But oh man, so then she lands right. She lands on this anthill, this fire anthill, and somehow is still, she survives somehow. Well, the fire ants, of course, are really pissed because their house has just been, you know, probably devastated. Just this big explosion, right? So they're pissed, right? So they start stinging her, and the venom um, causes her body to create um, um, this adrenaline rush that keeps her heart beating long enough for the doctors to stabilize her, I guess. And wow, but what a what an incredible story! What an incredible story. So yeah, sorry, I didn't mean to get um, that much into that, but it's absolutely fabulous. It brings a smile to my face for sure. It definitely made my day. Definitely made my day because it's just it's like down and up. And it's like, oh, parachute failed, and then she survived, and oh, the fire ants bit her, and oh, she still survived. So yeah, pretty amazing. Pretty amazing. Um, so yeah, you know, since I'm thinking about astronomy anyway at night, it's like let's just open this up to the rest of the world, see what happens. Um, this is really really easy. I was sort of warned that I'd get burned out, that it would turn into a chore. No, this is really, really, really easy. It's just um, the and I'm glad that I have this alarm on the smartphone because that's probably the only thing that is keeping me consistent enough. Otherwise, I mean, I don't think I would necessarily forget, but I would lose track of time, and so I may not uh, always um, be here at 2 hours UTC. But because of this alarm on my smartphone, uh, it makes a sound and it's like, okay, I need to go do the live stream. So it's super, super easy. And, uh, and as I said, I don't consider myself any kind of a expert. I think that's unnecessary pressure. Um, you know, I think a lot of times scientists are sort of put up on pedestals as sort of the high priests, and so when we have questions, when there's something that needs to be explained, we all run to the high priests and try to get the answers, and the high priests are under an obligation to give us answers because they've said that it's like, hey, if you want the answers, come over here. I will tell you. I will tell you all the answers. And so they've set themselves up. Now, I'm sort of exaggerating a little bit, so don't take this too exactly. Um, but set themselves up, as being those who have the answers. And what I notice a lot is that they are googling um, on this information and reading it off of a screen, and because they know some things about this, they can sort of make interpretations, and also create a conversation about the topic, even though they may um, 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 just be reading it for the first time. Nothing wrong with that at all. I mean, I'm doing exactly the same thing here. Uh, it's just I'm not going to claim that I know things or have the answers or anything like that. So and that and that's the other thing is that this live stream is completely unscripted, unproduced, um, cheap camera, terribly cheap microphone. It's running on a laptop that uh, definitely uh, is going to fail at some point. But you you stick with us, um, because I need to be running um, Google Chrome in order to have um, the Hangouts, and my Linux machine won't do, and I don't. I've got a couple of Windows XPs, but I don't know if Google Chrome is going to run on those or not. I suppose I could try them. But anyway, this one is running Windows 7 and Google Chrome, so it is working out. There is no production. There's no fluff. There's no anything else. Now, if I could be running OBS, I would, because OBS, I um, uh, I've got it installed actually on this laptop, and when I got it installed, I started playing around with it, and I think it's awesome. I think it's awesome. I also like the fact that it's free and um, open source. So as a programmer, I can appreciate that. If I want to see how they're doing a particular thing, I can look at the source code and find out. Or if I want to add some functionality, um, I can do that too. I've got a kitty that is howling at the door to be let out. See, I I am doorman. I am doorman to Kitty. So when Kitty makes a request that the door be opened, either to come in or to go out, then I must respond because that's my job. So I will be back with you in like 10 seconds. Hold on. Okay, Kitty is happy. Kitty is happy. So that was the other thing that I noticed about the other podcasts is that there was always a script, there was always sort of like an agenda, a topic, that kind of thing, and I found a little hole in that let's not do any kind of specific topics. Let's not try to pack a lot of things into one show because it's a weekly thing. This is just a fun, casual, um, um, daily show. So yes, bow to the feline overlords. They, Uncle Bill, I convinced myself several years ago that cats are actually much more advanced than humans, and I base that on a number of things. But two things that I notice is that um, they seem to really enjoy themselves. They seem to be, most of the time just very content and just sort of, you know what, I am alive, and that is good enough. And as long as I can eat and drink and sleep, I'm good with that. So I actually think that's pretty advanced, because we humans, oh my God, we're scurrying around like insane little ants, right? Just crazy, crazy, crazy. You know, uh, it's just crazy. And these guys are just, for the most part, just relaxed and everything else. The other thing that I notice is that they are very very advanced and very very good at meditation. They will sit with their eyes closed, awake, and they who knows what's actually going on in those little heads of theirs. But it looks like from the outside that they are in deep, deep meditation. They are somewhere else. They're somewhere else, and I think that's fabulous. So I take a lot of lessons from cats, and yeah, I actually do. I mean, I'm pretty close to thinking that they are a more advanced um, um, species than us. So, hey there, Bob Dog. How's everything going up there in the frozen north? Hope everything's well. Man, it's warm here. I've been getting. I think we're going to be getting into the mid 70s Fahrenheit during the day, and yeah, it's starting to feel warm. So yeah, very very nice. Cloudy though, cloudy. So no observing, and I wanted to move into that. Let me get some. This is hydrogen hydroxide again tonight. Very relaxing, very chill, very mellow. HOH, hydrogen hydroxide. Cheers. Mm, it's still snowing. Oh man. Well, Bob Dog, the thing of it is that if you like where you are, then enjoy, right? Uh, yeah, I can't comprehend um, wanting to be anywhere else except here, but even here, definitely isn't for um, everyone, and I'm glad because it's nice and quiet. It's nice and quiet. The population is extremely low. It's really really nice. But if you're having a good time and you can put up, with snow and stuff, cool, cool. I'm all for it. The Solar Cat Book of my teenage years, clear proof of feline intelligence. The Solar Cat Book? I've never heard of this. I've never heard of this. So yeah, I'm gonna, Bob Dog. It's not too winter. It actually starts. It's at 16:15 UTC on March 20th. So that's 11 days, less than 11 days, um, 10 days and change now until the equinox. So yeah, less than 2 weeks. Pretty amazing, pretty amazing. But I would think that your winter probably extends, probably into May or so. Yeah. Uh, Relative to you, I don't have a winter. Relatively speaking, here, yeah, yeah, we have a winter. It gets cold. It gets cold. I mean, we can drop. Um, Sometimes we can drop um, below 0 Fahrenheit. That's happened quite a bit. This year we never did. We never did, and it's very, very unlikely that we're going to now. We'll probably get another cold spell or two. We've had actually snow the 5th of May. So, our snow doesn't last. So, it's just sort of flakes floating in the air. As soon as they hit the ground, they basically evaporate. So, um, but yeah, let me move into talking about the observing project. Um, can't can't say much about sort of the big plans yet, but what I'm doing at the moment is I'm trying to characterize this telescope and my CCD camera just to see, how good is it. Um, so what I can do is I can do um, 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 astrometry, and I can do photometry. So I can measure the positions of things, and I can measure the brightnesses of things. That's fundamentally what this um, system is. So that book is free on Amazon. Okay, I'm gonna get it. I'm gonna get it. So yeah, interesting, interesting. And so what I was doing today was uh, I was getting around to looking at photometric accuracy. So how accurately can I measure the brightnesses of stars? And so what I have to do there, it's relatively simple, is that I have to go to a catalog, and I've chosen Gaia because it's a catalog that has lots and lots and lots of stars, goes down to like 20th magnitude, or sorry, 20th magnitude or 21st magnitude, something like that. Just a lot of stars, a lot of non-stars as well, um, and of course there are magnitude measurements with actually an unusually large number of decimal places. I think I was seeing. Well, I can actually look on my spreadsheet here. By the way, just saying, spreadsheets are awesome. Hope you all agree with that. So the Gaia magnitudes are 10. No, sorry. Um, yeah, are yeah 9. No, 11. 11 decimal places. So, which, in all honesty, I think that's kind of ridiculous. I mean, obviously these are calculated, and so somebody doesn't really understand the idea of 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 you know of um, uh, and I'm forgetting the term, the significant figures. Okay, somebody doesn't quite understand the concept of significant figures. Okay, a magnitude. Okay, the brightness of a star to the 11th decimal place is ridiculous. It's absolutely ridiculous. Hundredth of a magnitude, thousandth. Kepler is probably seeing thousandth, some thousandths of a magnitude differences in some of their measurements. I think they're significantly more than that. Uh, maybe uh, you know, well, um, at least hundreds. So, to go out 11 decimal places, it's a little funny. Anyway, what I did was I chose the 9 brightest stars in the field of view that I've got data for, which is a portion of the open cluster of stars called M41. And M41, by the way, is a great binocular object. And if you're in a dark sky like mine, you can actually see its naked eye. It's just south of Sirius, probably, I don't know, 2 fingers, maybe 3 fingers down from Sirius, south. Not exactly down, but south. Um, so, grab some binoculars and take a look at that. If you've got a scope, of course, take a look at that too. But I looked at the 9 brightest stars in my field of view, and I identified each one of them in the Gaia database. And these brightnesses go from, I'm gonna pull up my other spreadsheet here. Whoop, is it this one? So these brightnesses go from 6.29 down to 10.84. So none of these are visible to the naked eye, but they're actually the brightest ones in the field. I think there are some brighter stars in that cluster itself, but I was sort of off to one side. So I chose these nine bright ones. So at the moment I can't do um, um, absolute photometry, that is, um, directly measure the magnitudes of these stars, but I can do relative photometry, which is saying, okay, here's the brightest one, here's the next um, brightest one. What is the magnitude difference between those two? And then I can do that for all the other stars. So I just chose, um, um, the brightest star as sort of the standard. And then I looked at the differences in magnitudes between that one and all the other ones. And those numbers I can actually then use to compare to my measurements of flux um, in order to get magnitude differences. And so that's just a simple equation. It's a logarithmic equation. It's just the flux of my standard divided by the flux of, 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 of the second star. I take the log base 10 of that. I multiply it by negative 2.5, and that is a magnitude difference. And so I can compare my measurements of differences to what Gaia says that the differences are. And I'm pretty happy with the results. I'm pretty satisfied. The data that I have is not calibrated at all. So I haven't dark subtracted. I haven't flat fielded. It's out of focus. The tracking for the exposure time is okay. Given the the input data, and as they say, garbage in, garbage out, it's absolutely true. But given what uh, I've got, um, given what I've got, and making the measurements that I can, there's pretty good agreement. I'm pretty satisfied. I'm seeing, I'm, I'm actually looking at the numbers here. As I said, spreadsheets are awesome. So depending on how I measure the flux, there are sort of different ways of doing that. But depending on how I'm measuring the flux, I'm seeing an average difference between my measured differences and Gaia's differences. I'm seeing an average difference between my measurements and Gaia of like 0.2 magnitudes for a couple of different ways, and 0.07 magnitude, so 7/100ths of a magnitude average difference with those nine stars. So that's not too bad. Not too bad for, it's not crappy data, but it isn't, scientifically valid data. So I'm pretty excited about being able to get back onto the sky, take my flats and my darks and biases, and actually reduce this data down, take all the systematic stuff out of it, and make these kinds of measurements again, and see how close I can get to what they actually are, at least what the differences are. So but I'm pretty pleased with that, being able to um, um, measure things, to an accuracy, to an average accuracy, of 7/100ths of a magnitude. Not bad, not bad. And really, I'm looking at all of the differences. I measured the flux 3 different ways, and I'm looking at the differences between um, um, Gaia and what I measured, and I'm not seeing anything more than about 1/3 of a magnitude difference. So that ain't bad. That ain't bad at all, and they're consistent too. So yeah. So yeah, I'm pretty happy with that. Pretty happy. As I said, I'm really anxious now, to get some calibrated data, make these measurements again, and see how close I can get. But preliminary look at this is very promising. Very promising. Still, 2/10ths of a magnitude, mm, not good enough for science. That's some pretty yeah, the accuracy there isn't great. And actually, the precision on all of these is running about like 0.15 magnitudes, 0.13. So the accuracy is pretty good. The precision is good. So so far, I'm pretty happy with that. So I'm probably gonna do this for many more um, um, pictures. I've got lots and lots of data. I've got at least 100 images. So I've looked at one. So I am definitely going to be running this through. I'm sort of building a pipeline, to process all this stuff, so I don't have to manually do it. It just means writing some code, no problem, no problem at all. But this is very encouraging, very encouraging. So to this weekend's task, probably tomorrow, is I'm going to switch to the astrometry, to measuring positions and seeing again. I'm going to do relative astrometry, which means I'm going to take probably the brightest star again, and use that as a reference position, and then measure all the positions of the stars from that. I know what the pixel scale is, how many arc seconds per pixel I have. So it's just a matter of measuring the number of pixels between the reference star and the star that I want to measure the distance to, and then multiplying it by the pixel scale in order to see how far that star is away from the reference star. And I'll do exactly the same thing. I'll compare it to the Gaia positions, and I'll do exactly the same thing I did measuring brightnesses. Uh, I'll get a value for the accuracy and a value for precision, and hopefully I'll be able to report back here and say everything looks really, really good. Preliminary looking at that, I think the astrometry is going to be very, very awesome. Astronomy, um, the astrometry isn't as reliant on calibrations. Um, it is if you want to get subpixel thing, because you want to be able to centroid, and if there's any kind of funny business, hot pixels, or any kind of weirdness at all, it's going to change slightly the position of the centroid, and that's going to change the measurement. So um, calibration is still extremely important, but when it comes to astrometry, it's not as important. And as I said, I've run some of these images through um, um, the website astrometry.net, and there is very, very good agreement with all these things. So yeah, pretty happy with that. But yeah, I'll be making sort of an assessment using Gaia and my own means of measuring centroids, measuring the positions of these things. I've written the software already to do it. So it's just a matter of running it through and then putting the results up on the spreadsheet and doing the calculations to see how close those measurements are as well. Cheers. So let me pull up the chat here, make sure I'm not missing anything. Missing anything? Okay, nope, not missing a thing. All right, well, cool. Let me share my screen. We can look at this paper. Go to infinity. Hide that, and we're going to go to the paper. So science objectives of the Ganymede Laser Altimeter, GALA, for the JUICE mission. So as I said, JUICE is a spacecraft that obviously is going to be going to Jupiter. They say here that it's supposed to launch in May of 2022, interplanetary cruise for 7.6 years, Jupiter insertion October 2029. And then it'll orbit Jupiter for 2.5 years, do a couple of flybys of Europa, Ganymede, and Callisto. Pretty close, 200 kilometers, that's pretty close. And then once that's done, then it's going to go into a parking orbit around Ganymede, and that's where it's going to. Well, they say here it's going to be there for at least 10 months. I don't know if they said anything about exiting that orbit or not, or if they're just sort of stuck there. So this is just a description of this instrument. Apparently, there's like 10 instruments on JUICE, and GALA is one of them. And it's just a laser altimeter, uses a laser at a wavelength of 1064 nanometers. So that's part of the infrared. Not quite sure why they chose that. Maybe it's yeah, I don't know. I don't know. But the beam size on the ground from 500 kilometers away is going to be 50 meters. So it's a pretty big beam, pretty big beam. Not quite sure how much power. I don't know if they say that anywhere in here either. But not too bad, you know. Uh, nice, nice resolution there. They say elsewhere in the paper that they're going to be able to measure topological features down to about 5 meters. So that's pretty awesome. And, this is a pretty basic instrument. Uh, they shoot a laser beam down. It's running at 30 hertz. So 30 times a second, it sends a pulse down to the surface and then looks for reflections, and it's able to time how long it takes the reflection to come back to it. So uh, uh, we know the speed of light. Supposedly, we know it. Although the speed of light seems to change from time to time until they, by decree, I don't know if you knew this or not, but by decree, the speed of light was set to a value, um, partially because, um, for the most part, every time they went to measure it, it changed. And, oh, we can't have a constant changing. That's a contradiction. So back in the 1970s, it was decreed that the speed of light was a certain speed. And of course, after that, it is a constant. It doesn't change. So, but it's kind of interesting, that it seems as though, at least according to the measurements, the speed of light does change. And what is that all about? I don't know, but nobody wants to think about that. That's a bummer. I think it needs to be investigated. So, since we know supposedly what the velocity of light is, and we can time how long it takes, the pulse to reflect back up to the spacecraft, we know how far that pulse traveled, and so we can get a measure of 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 topography um, very very accurately. As I said, I think they were saying it was around 5 meters, so that's not bad. So they're targeting the icy Galilean moons. So that would be Europa, Ganymede, and Callisto. Io is definitely, well, it doesn't appear to be too icy. So they're focusing on the icy moons because they think that there's some excitement there, and I'm sure there is. Ganymede is the largest and most massive satellite in the solar system. Ganymede's larger than Mercury. So, science objective of the GALA instrument. Closest approach, flybys, going to be going by Europa and Callisto, and then orbit Ganymede. Yeah, we already talked about that. 500-kilometer altitude orbit around Ganymede allows for a global coverage of the entire moon. Cool. So they'll be able to map the entire moon with 5 meter resolution. That is going to be awesome. So one of the things that they're doing, they want to watch Ganymede sort of change shape as it moves through Jupiter's tidal uh, fields, and how it shrinks and expands and shrinks and expands. Uh, Apparently gives you some indication of what's going on underneath the surface. Everybody's really, really excited about, the prospect of finding liquid water on one of these moons because of um, what the implications of that are, right? If you have water around and essentially dirt, you know, mud and stuff, yeah, could be pretty exciting. Could be pretty exciting. I mean, if you're excited about life, uh, then the prospect for life, if there's liquid water, could be pretty exciting. I've never really been entirely understanding of why astronomers are interested in living things, or finding life. I think that's more of a biology thing, than an astronomy thing. But that's kind of a fuzzy line there, right? And I think there is actually a profession now called astrobiology. Although, if you think about it a little bit, uh, that doesn't exist. I mean, the only place that we know that life exists is here. So, and when you study life on Earth, you're a biologist, right? Uh, but I guess the idea is that there's sort of an assumption that at least at some point we are going to find life elsewhere, uh, and so astrobiologists will be studying that. Um, what they're doing now, I guess they're just playing with models, right? They're making guesses. They have some interesting data, from Kepler and other ground-based scopes that are probably helping them, um, 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 with their models. But at the moment, at the moment, they are living in fantasy land, right? They're living um, um, just in their virtual realities that are their models, and that isn't a criticism. I think it's really really important to be prepared, but I don't consider these people experts on life elsewhere, because we haven't found any yet. They're not really even an indication of it yet. Maybe some indications, but could be other things too. So again, to consider them, knowledgeable about life, it's like, oh no, 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 not yet. And that's the skeptic in me. But the open-minded dude is like, well, cool. I'm glad that they are preparing. I'm glad that they're hopeful, because yeah, I'm as excited about the prospect of life, not on Earth, as at the, that's going to be well, unfortunately, I don't think it's going to be as big of a deal, um, as some think. I think it is. It's going to be a paradigm shift, but not. I don't honestly. I People seem to be so caught up in other things that you know something alive on another moon or on another planet. Yeah, okay, all right. We'll be excited enough. We'll be excited. I think it's fantastic. I don't think it's going to change life as we know it, here on Earth. Could be wrong about that. I guess it depends on what you find and how strange it is and all of that. But anyway, this um, simple um, um, laser altimeter is going to be able to measure how Ganymede, specifically, sort of, you know, uh, changes its shape as it moves around um, Jupiter, and how it changes its shape, and to what extent it does that. Um, can give us an indication of what's going on inside, and you know uh, maybe there's going to be some water there, liquid water. Don't know. Sorry, I meant to show you some pictures. Let's see. Europa perform altimetry at an altitude of 1,300 kilometers. That's pretty good resolution. Uh, diurnal tidal responses. Spacecraft will conduct multiple measurements at many geographically fixed locations and will provide a time series of surface displacement. So yeah, this is the squishing and expanding uh, as Ganymede orbits Jupiter, and so they're going to locate some locations to measure multiple times, and then they'll see how it changes over time, if at all. Probably it will, probably. And that's going to tell us all kinds of things about what's going on inside. At least we can infer things. I mean, the only way to really know, right, is to slice the planet in half and look, uh, or do like seismology, that kind of thing. That's more of a direct way. But we're going to be able to infer some pretty interesting things about um, Ganymede. But there's some pictures here that I was looking at that I really don't understand, so I'm not going to try to explain them. But I do like plots and graphs. This one's very complicated. It's got some interesting structures in it, and it says that it's the distribution of the love number H2 for, and in this bottom one, for cases without an ocean. So I don't know. I don't really know what those things are talking about. Small scale roughness, slopes and roughness are important parameters for quantitative studies of surface characteristics. These parameters measure an interplay between various processes that modify a, a planetary surface. Okay, so yeah, they're going to look for uh, you know um, changes happening on the surface itself as well. So that's very cool. Let's see. Wow, I'm already past an hour. That's amazing. Time flies when you're having fun. Hope time flies for you folks as well. Yeah, don't know what these are, but they're pretty pretty neat looking pictures. Um, Possible synergy of other scientific instruments on board JUICE spacecraft. Characterization of the icy Galilean moons will be achieved not only from the GALA measurements, but also by synergy of the various scientific instruments on board JUICE. Uh, let's see what synergies though. Um, yeah, they don't really explain in which what how they're going to work um, in a synergistic way, just that they are. So, okay, that's kind of funny. If I were a referee, I would sort of wonder about exactly what they're talking about there. But what they're saying is that many of the instruments on board are going to sort of support each other. So um, um, GALA will support Janus. Janus will support GALA, and in so doing, right? And this is synergy. What we learn will be greater than the sum of the two parts, which is very true. Very true. So yeah, sounds like an interesting project. It looks like it's going right. I mean, it doesn't look like this doesn't seem to be like it's in any kind of a theoretical planning stage. It looks like they're actually going. I mean, especially if they're only 4 years out. Uh, Man, they got to be bending metal by now, right? Gotta be, gotta be, gotta be. Always references. References are uh, windows into the past. Um, looking at the history of different concepts. This this is this is the first step into the rabbit hole where you can go back in time and oh, there's just so much to learn. Any of these papers is just a launching pad for learning a lot, not only about the subject matter itself, but also the history of the um, um, subject matter. So it goes all the way back. You can hop references uh, as far back as you possibly can until there's got to be some kind of a beginning. And yeah, we definitely look up to those kinds of people for sure. All right, I am going to stop sharing this screen. So yeah, that was from the archive.org from the 6th of March, 2018. So take a look at that. I didn't really uh, get a chance this week to look at many of the papers, either on this live stream or offline. So I'm going to be going through this past week's papers to see if there's anything else interesting. If if there is, maybe I'll talk about it here. If you find anything interesting at all, let me know. You can um, um, post it over on my Discord server, which there is a link below. Um, uh, let's see, if you're new here, make sure to subscribe. If you like it, hit the thumbs up for sure. If you don't like it, hit the thumbs down. Make some comments. I like to hear about what you think about this. Definitely want this channel to grow. Are there things that I can be doing or not doing um, that might I'm drawing a bigger crowd? Should I? I'm trying to be uh, vocal but not rude and obnoxious. So because I don't want to be a pain at all, but I also want a crowd. I think having a crowd in here would be really, really fun. Um, Great conversation that way. It'll keep me on my toes for sure, and the circle can just get bigger and bigger and bigger. So, all right, I'm going to get out of here. Make sure to share this too. Make sure to let um, um, people know about it who you think might be interested in this kind of stuff. As I said, I'm trying to fill a niche. And I think I have, and yeah, I think it can only get better and better and better. So hopefully, but yeah. All right, I'm gonna get out of here for now. Got to get back up to the ship. They are waiting. They are waiting. And I will see you again tomorrow, 2 hours UTC, same time, same place, right here, pretty much right now. But yeah, I will see you again in a little less than 23 hours. So hope you have a great day, great evening, and keep thinking astronomy. I am pretty much all the time. So yeah, great fun. Talk to you all later. Peace out.